Hey folks, Nathan here with lesson numero 2 of Learn2Python, a video series designed around example-based learning and teaching for Python. This is our Python main website, learntodo.github.com/learn2python, and no worries, that URL is at the bottom of the description below. And as you can see, we've added a lecture 2 and Python 2 files and Python 2 study guide. Before you start the lesson, go to this website, open up Learn2Python files, download it. Super important. Pause the video right now before you do anything else. Before I start lecturing about this exciting lecture up ahead, pause the video. Go to the website, scroll down to Learn2Python, lesson 2, materials, and download the Python files. It's only one file, shouldn't take very long. See you. If you found the right file to download, it should look like this single lonely Python file called chaos. If you haven't, go back and make sure that you have followed the directions and gone to the website listed below in the description. To open up chaos and to examine what it does, we're going to be doing kind of the same stuff we did last lesson. Right click, edit with idle. Another way you can do this is to open up idle manually and then go to file, open, and open chaos. Alright, to run chaos or to see what's going on, we want to go to run and run module. And as you can see on the left hand side, the program has been run. This is the innards of chaos, and we'll kind of look at that a little bit later, but first let's see what chaos does. Chaos first says this program outputs chaos. Enter a number between 0 and 1. Well, let's follow the instructions. Let's enter a number between 0 and 1.38. How about that? Hit enter, and whoa, some numbers just appeared. Let's try running this program again. And typing in 0.67. Whoa. Alright, what's going on here? Well, the program obviously asks us, print some text out, and then asks us to enter a number, and lets us input a number. After we input a number, it outputs a set of 10 numbers that seem fairly random. In fact, some would say this output is chaotic. Anyways, what makes an output chaotic? Well, just that. The output, if the output looks random, and if it looks like each successive number isn't related at all to the previous number, and there's no discernible pattern, then we call this a chaotic system. For instance, if you see here, I type in 0.38, and that gives us the answer of 0.89 first, but then it goes to 0.35, then 0.87, then 0.42, etc., etc. And then when we go to 0.67, then it goes from 0.84, which is fairly similar to 0.89, but then the next number is really different. It goes to 0.51, which is different from 0.35. And then on and on and on. So you can see the outputs here are fairly chaotic. This is a really neat program because it demonstrates a lot of basic concepts. Let's look at the code and see what we can tell from the code. Before I get further in terms of talking about the code, I do want to say that I have borrowed this example, or this example was inspired. It's very similar to an example from John Zell. John Zell is a professor at Wartburg University, and he wrote a book called Python Programming: An Introduction to Computer Science. You can find it on Amazon. I will have the link below for you. And it's a fantastic introduction to computer science in general, but also to Python. And like me, he teaches in a very example-oriented way, which is something that I really enjoy. If you're serious about learning how to program in Python, this is definitely a good book for you to get. Pause the video now, open up idle, open up chaos.py, and play around with the program. See what chaos does. Try inputting various numbers, seeing if inputting a number that's greater than 1 or less than 0 actually breaks a program. When you're done exploring, come back, unpause the video, and start playing again. Now that you've had a chance to look at what the program does, let's go back and figure out what the code is doing and how that impacts the output of the program. The first line of the code is fairly straightforward. Def chaos. We understand what that means. Define a function. A function is called chaos. Our function chaos has no parameters, and the colon just says anything that's indented under this is part of the chaos function. Cool. All lesson 1 stuff. You have problems with that? Go back to lesson 1. Print. This program outputs chaos ! All good. This is a print statement. This is a string literal. Hence, it will print out the string literal, literally. So we see here, this program outputs chaos ! Fantastic. We're 2 for 2, and then we're going to hit 3. Oh, geez, what's going on? X equals to eval input, enter a number between 0 and 1. What's going on? Okay, well, let's look back at our output and try to figure out what's happening in the input. We have enter a number between 0 and 1. Okay, we can see the similarity here. We can see that possibly that line 2 of the output is related to line 3 of the input. All right, makes sense, makes sense. What else can we infer? Okay, we have this input statement. What does the input statement mean? Okay, well, we have to enter in a number. We have to enter in 0.38 or 0.67 down here. So the input must mean that this turns into an input. It turns into a prompt. It turns into a question that the user can answer. Okay, that makes sense. So if you type in input the input statement, and you put something between the parentheses, then it asks for an input. This is all very readable because Python was designed from the ground up to be a very human readable language. That is to mean that Python has a lot of human words embedded within the language. We can see that there's a define here, print, evaluate, input, for, in, range. These are all very human words, and these are very understandable by humans, and also apparently our computer can understand it now as well. When one writes code, it's very, very important for you to keep as closely as possible to human readable words and human logical words. What do I mean by this? If our function outputs chaos, we should name our function chaos. That's a logical name, and that's a human word. If you name your function something like that, that may be cool and unique, but not only is that hard to type again, but that's very unintuitive. People have no idea what chaos means. So when you name your functions, name them something unique, name them something useful, name them something understandable, and name them something, very importantly, that makes sense. Now if we look down here, there's an x value, and this x variable rather, well, what does this x value mean? This is a good example of a poorly named variable. Well, we've just discussed that this line right here is essentially just to get an input from our user, right? It's asking us for an input from our user, and the user inputs 0.38 or 0.67. So where's that input going? Well, that input's actually getting stored by this equal sign, and it's getting stored to our variable x. So really this input from our user is in mathematics what we call the seed right? Like a seed of a plant. It's a seed for our chaos. It's what determines how chaotic our system is. It determines where the chaos is moving within our system. So why not call it just that? The chaos seed. Now, remember, if you want to change the variable here, we need to change the variable here, and also here, and also here, and also down there as well. Because remember, if they don't all have the same name, then they won't all reference the same thing. Now that all the chaos seeds are all the same name, they all have the same value. Alright, so line 3 we've taken care of. Chaos seed is our variable. We're asking for some input from the user, and we're storing this input to our variable named chaos seed. Line 4 is the coolest thing in computer science. It basically sums up why computers are so much better than humans at doing some things, and this is why computers are special. This is what we call line 4 is special. Line 4 is called a for loop, and for loops line 4 is called a for loop, and loops in general makes computers awesome. What a loop does is it lets you repeat an action over and over and over again, just like if you were stuck in a loop or stuck in a circle. You just kind of keep on going around and round and round in circles. And the for loop is one type of many types of loops that do just that. It makes a computer go round and around and around and around in circles, doing the same action over and over and over and over again. This is awesome. This is great for computers. This is why computers are so special. Before we try to first understand the for loop, let's understand the concept of a loop. Here I have an example that should be fairly simple. Our chaos seed is 0.5, and we have our for loop right here by itself. Let's run the module, say OK. And as you can see, it runs over here, and it just outputs this. It outputs 10 numbers. All right, that's pretty cool. With 3 lines of code, we basically output 10 lines of output. And it'd be awesome if I told you that you could actually up this to 100, and that would give us 100 lines of output. And you know what? If you're feeling really lazy and you want to generate 1,000, you could just do that just as easily, and you can generate 1,000 lines of output, of chaotic output. Now, how would you have to do that if you were like a human and you'd have to do each task manually? Well, that's a pain in the butt, actually, because remember, our chaos seed is 0.5, but remember that we have to execute each task over and over again. See, we'd have to type chaos seed equals to 3.8 times chaos seed times 1 minus chaos seed, print chaos seed over and over again. If we had to do this 1,000 times, we'd have to copy paste this 1,000 times. That's a huge pain in the butt. And you can see the code here is the exact same. It has the exact same output, except it requires much less work on your part, which is why loops are awesome. Looking back at the loop example now, let's figure out what's really going on. We've already seen that by modifying the number here, we can increase or decrease the amount of lines output. All right, well, why is that? to understand that, we actually need to look at the first three words. For I in range 100. What this is really saying, remember this is as English as they can make it. This is really saying that for some variable I in range 100, execute the code below. Now, what does that actually mean in plain English, right? Well, what that means is if some variable I is in range 100, then execute the code below. So, what that really means, or what this for loop really is saying, that if our variable is in our range, then execute the code, and then repeat, and then repeat, and then repeat, and then continue to repeat, and then continue to repeat, and continue to repeat, until the variable I is outside of the range 100. Now, if you're not that great at math, or if you can't think of numbers in your head very clearly, then perhaps an example might suffice. Instead of having all this chaos seed stuff, let's just tell our program to print the value of I and hit enter. Oops, rather, sorry, and hit run. Yep. Okay, whoa, cool. So what we're doing here is we're printing the value of I in this for loop. You see 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Wow, this program is counting from 1 to 100. Oh wait, it's only counting to 99. Why is that? Well, it's counting from 0 to 99, so it actually counts 100 numbers, but it starts from 0. This is something that you have to remember in computer science, and in math, and in a whole bunch of other disciplines. People like to start counting from 0 instead of 1. So when you say from I in range 100, you're really saying count 100 numbers, but you start at 0. And we'll look into some cooler applications of the range a little bit later. But for now, understand that by typing in range 100, what you're really doing is counting 100 numbers from 0 to whatever. If I wanted to count 10 numbers, same thing. It just counts from 0 to 9. If I count to 9, same thing, with 0 to 8. So what does this have to do with anything at all? Well, remember that every single time this for loop runs, it adds 1 to I automatically without you having to do anything to it. As you can see here, it counts 0, 1, 2, 3, 4, 5, 6, 7, 8. And then once I reaches 9, it says, oh, I'm done. No more. This is very important because our chaos seed and our chaos program relies on this idea. We want to output a set of chaotic numbers. And to do that without having to copy and paste hundreds and hundreds and hundreds of times if we want to output 100 numbers, all we have to do is tell our computer to execute a for loop. And we can say that for our I in range 9, or range whatever, execute this code. But once the I value is above 9, or above 9 numbers, then stop. Stop executing. Pause the video right now. Try writing your own for loop. For I in range 9. or for I in range something, and then print out whatever you want. Print out I, print out hello 10,000 times, play with it. Pause the video, come back whenever you're ready. Welcome back. I hope you've had some time to play around with the for loop, and I hope you understand exactly what it does, or at least if you don't understand exactly what it does, you have an idea of what it does. The for loop is a structure that we use in computer science to loop an object over, or loop some code and execute it over and over and over and over again without having to copy and paste, which saves us the trouble of doing it over and over and over again. Back to our chaos program, we have understood 4 of the 6 lines. We're almost there. Well, we have chaos seed equals to 3.8 times chaos seed times 1 minus chaos seed. And this is what we call an assignment statement. Just like up here, we're assigning some value to our variable. However, in this case, this is cool. We're assigning some new value to an old variable. We're saying chaos seed used to equal 0.5 or 0.38 or 0.47 or whatever. And now it's equal to whatever we choose it to be equal to. And of course, this is just a mathematical equation, 3.8 times our chaos seed value times 1 minus chaos seed. That's just one way to produce a chaotic system. But this is so cool. We're basically saying chaos seed equals to chaos seed with some numbers added to it. And as you can see in a loop like this, this adds change. As chaos seed gets modified, on the next iteration of the loop, it gets modified again. On the next iteration of the loop, it gets modified again. Therefore, a chaotic equation here would produce a chaotic outcome. And to see that outcome, we just print the number chaos seed. And remember, since chaos seed is a number, we don't need to put quotation marks around it because it's an expression, so we can evaluate it and print it. So in summary, this 6-line program can output as many chaotic sets as you want. And it does this by first defining the function named chaos, then adding the colon to show that anything underneath the colon is part of the function. And then it says print out this program outputs chaos. Oops. Yep. There we go. Then it prints out this program outputs chaos, just like this. And then it prints out, it asks us to input a number, enter a number between 0 and 1. So let's enter 0.45. And then once we hit enter, it actually evaluates that 10 times using this for loop. And it just goes around and around in circles 10 times, and it prints out a different value each time. That's pretty darn cool. I know I've given you a lot to digest this video, but no worries. Take a break, come back to the chaos program, play with the code, see what you can add and remove, modify. You know, can you add another number here? Can you change the range? Can you change the print statements? Whatever. And stay tuned for the exercises video coming out tomorrow. And as always, please let me know in the comment section below or send me a question via the form on the website if you have any questions or comments or suggestions, or if you have any topics you want me to cover. Thank you very much.